This meeting is being recorded.
In this next video from chapter 19 on electrochemistry, we're going to take a look at our final balancing example here, but this time we're going to see how to balance in basic solution. So we're going to do everything that we did to balance in acidic conditions, but at the end of our acidic balanced equation, after we find that, we're going to add OH to each side to neutralize. So we're going to add the same amount of whatever H plus there is. We're going to create water in its place. So we know that OH plus H gives us H2O. Right? So that's what we're going to do to convert this from being in acidic conditions to being in basic conditions. You always know you're in acidic conditions because you see H plus in your final balanced equation. Now we're going to see OH negative in our final balanced, our overall oxidation reduction equation after we balance it in our basic solution. So let's take a look at what the differences will be here. So we start off pretty much the same. We're going to split our reaction into two half reactions. So I'm going to split that based on I need to group anything other than oxygen or hydrogen together. So now I have CN and CNO on this half reaction, and then I have my permanganate ion and my manganese oxide over here as my product. So I've separated into my two half reactions. Again, we're going to balance this in acidic conditions first. So I'm going to balance everything but oxygen and hydrogen first, then go back, balance oxygen, then lastly, add some hydrogen initially before we convert to basic. So C, N looks good. The same amount over here. So we don't need to add any carbon or nitrogen or multiply by any coefficients. I will need to add one H2O over here. All right, so now our oxygen is balanced. Next we have our manganese, so everything looks good with the Mn. They're already balanced. We need to balance our oxygen. I have 4 on the reactant side. I have 2 on the product side. I can multiply this by 2. Now I'm balanced as far as my manganese goes. Let's take a look. What else do we have to do here? Now we have uh, 4 oxygens. Oh, I'm sorry, we don't need to add that too. We're going to add 2 water molecules. I apologize, our manganese is already balanced, so we just need to jump right to the oxygen here. So we'll add 2 water molecules, and now we're balanced. So let's balance our charge next. So I have 0. Oh, I'm sorry, we have to do our H plus. I'm jumping ahead. I'm so excited to balance in our acidic conditions or in our basic conditions. We need to add 2 H plus over here. And then I'm going to add, since we added 2 water, we're going to add 4 H plus over here. Okay, all right. Now I think I have everything in order. So let's go and rewrite these equations. So now we have H2O plus Cn negative gives me CNO negative plus 2H plus. And then over here I have 4H plus MnO4 negative, and that gives me MnO2 plus 2H2O. All right, so everything but the charge has been balanced at this point. Let's take a look how we can do that. So we have 0, -1 is our net charge over here. And then I have -1 and +2 over here. So +1 is my net charge over here. So that means that I'm going to have to add 2 electrons to this side to get me from +1 through 0 down to -1, right? I have to reduce by 2 to make these equivalent. So I have added 2 electrons over here. Let's see, what do I have? I have +4 -1, so I have a +3 net charge here, and then I have 0 and 0. So I know that I have 0, so I have to add 3 electrons over here. All right, so it looks like we're going to have to multiply by 2 or 3, depending on how many electrons we need to end up with. We need to end up with 6 for both of these equations. So I'm going to multiply this one here by 2, and then this equation here by 3. So at our next step here, we're going to have 3 H2O plus 3 Cn, and then we're going to have 8 H plus and 2 MnO4 negative. On the product side, I'm going to have 3 CnO negative plus 6 H plus. And then from the other half reaction with manganese, I'm going to have 2 MnO2 plus 4 H2O. Okay, so we're getting closer. Now we can cancel out if we have water on both sides. We do, so I'm going to subtract 3 from 4. So I'm going to end up with 1 over here, so just 1 water molecule there. I can also cancel out, or subtract rather, 6 of these H plus from the 8 over here, so I'm going to end up with 2 H plus. It looks like everything else is going to remain, so I'm going to have 3 Cn plus 2H plus 2 MnO4 negative. Then we're going to have 3 CnO negative plus 2 MnO2 plus just 1 water, H2O. All right, so now I balance this in acidic conditions. So to get this into basic conditions, as mentioned above, in the initial steps, we're going to have to add some base to both sides to neutralize our water. So I need to add plus 2 OH, so this will give me 2 H2O here. And then over here, I'm going to add plus 2 OH. So we add the same thing to both sides. So now we're going to cancel this water with one of these. So my final overall equation will have water on this side. I'm going to have 3 Cn negative plus 1 H2O plus 2 MnO4 negative. And then on my product side, I'm going to have 3 CnO negative plus 2 MnO2. And then I'm going to end up with a 2 hydroxide ions as well. So overall, I know that I'm balanced in basic conditions because I have no H plus and I do have OH in my final overall balanced redox reaction.